So section 8.4, and we're looking at working with vectors. And hopefully we're used to this idea. A vector is a quantity with both a magnitude and a direction. Now, you will also be used to this idea of a vector, something like 2, 3, and that means 2 across in the x direction, 3 up in the y direction, and it would be an arrow like that. Okay. Now, this is a two-dimensional vector. Let me just draw it without the scribbles on it. 2 across and 3 up, something like that. This is a two-dimensional vector because we need an x direction and a y direction. What I'd suggest with section 8.4 is just get used to the idea of vectors going in one dimension, because that's what we're going to need for the next chapter. And by the time we get onto two-dimensional vectors, we're much more used to mechanics. So a one-dimensional vector is one dimension is just moving along a straight line. So as far as we're concerned, a vector in one dimension is either going that way or it's going that way. They're the only possible directions. And we need to call one of those directions positive, one of those directions negative. So usually on our diagrams, we'll draw the diagram so that positive is going to the right and negative is going to the left. It is sometimes useful to draw diagrams the other way around. We will quite soon get onto things where you've got vertical motion, things are moving up and down. And in that situation, positive is often up and negative is up and down. But again, there's plenty of questions where you'll want to put positive being the downward direction and negative being the upward direction. But that's really what we're saying here with vectors, is we're moving along, we're doing with one-dimensional vectors, and that just means a number with either a plus or a minus assigned to it, okay? Some words that we're probably used to, but let's just quickly see them anyway. Displacement is the vector version of distance. Velocity is the vector version of speed. Acceleration can be thought of as a vector quantity straight away, and it is the rate of change of velocity. Okay, so that is the change in velocity over time. Force is a vector quantity because it's happening in a direction. If we're pushing something, we're pushing in a certain direction. The weight is sort of the vector version of mass, isn't it? And not quite, because it's the force and a mass. A mass is a mass and a force is a force. There's different things, but they're linked. So we can think, the weight is the force which is associated with a particular mass. Time is not a vector quantity. We're not going to have negative time. Time can't move backwards. It's only going to move in one direction. So it's always got a plus symbol on it. So time is not going to be thought of as a vector quantity. And what I think is helpful later on when we do start dealing with I and J vectors, which we do even straight away in this section, but these two bullet points at the top of this page, really for this, like I say, for this chapter, the important thing is get your head around one-dimensional vectors. We'll come back to this later, but these two bullet points are incredibly useful, and if you can kind of cement these in your head now as phrases that when you start dealing with two-dimensional vectors, it makes things a lot easier. So distance is the magnitude of the displacement vector. So if you've got a vector, it tells you about displacement. That means that you've gone a certain distance. So if we take this vector here, I've gone that far in this direction. I started here, I ended up here. The distance I've gone is the magnitude of that vector, is the length of that vector, okay? And similarly, speed is the magnitude of the velocity vector. So if I'm moving with a certain velocity, I'm moving with a speed in a direction. The speed I'm moving at is the magnitude of the vector. So distance is the magnitude of the displacement vector. Speed is the magnitude of the velocity vector. It's really important to get those two sentences in your head. Now, in terms of one-dimensional vectors, it's really in example 5. If you understand example 5, then we should be set up for the next chapter. So let's see how example 5 works. I'll stop trying to fold that because I'm making a mess of it. Let's start again. If we've got the positive direction going this way, we'll have a 0 point. So here is a 0 point, and that's what we're going to call 0. If I'm over here, anywhere over here, if positive is that way, this is a positive displacement. Doesn't matter if I'm moving that way, doesn't matter if I'm moving that way, doesn't matter if I'm speeding up, slowing down. If I'm in this part of the page, I've got a positive displacement. Over here, doesn't matter if I'm speeding up, slowing down, moving left, moving right, I have got a negative displacement. And if I'm here, I've got a 0 displacement, okay? If I've got a positive velocity, then that means that I'm moving in this direction. Okay, so a positive velocity means I'm moving in that way. So if I'm over here, This object here is moving in that direction. It's got a negative displacement and a positive velocity. Over here, this is a positive displacement and a positive velocity. This is a positive displacement. If it's moving that way, negative velocity. And, oh, what a mess. Negative displacement. Sorry, we'll stop for the clock. I'll try and edit that out, but we will see if I remember. So, negative displacement, negative velocity. So we're to the left of 0. That's our position, is negative displacement, and we're moving left, so it's a negative velocity as well. Okay. Now, hopefully so far so good. When we've got an acceleration involved, that's a little bit trickier. So if I start here and I'm moving this way, and I start slowly and I speed up, well, the acceleration is happening in that direction. I've got a positive velocity, I've got a positive acceleration. Here I've got a negative displacement. Once I pass that line, I've got a positive displacement. So I go positive velocity, positive acceleration means I'm getting faster and faster and faster and faster until eventually I'll shoot off the end, okay? That is positive velocity and positive acceleration would happen like that. It might help to think of an acceleration. An acceleration's always got a force associated with it, right? Something is causing the object to accelerate in that direction. So you could think of it as which way would you be pushing to make that change in velocity. So I could start here and have a positive velocity and a negative acceleration. So that would mean I start off fast and I get slower. So I start off fast and get slower and slower and slower. And eventually, if I keep the acceleration constant, what will happen is, so if I start off fast and get slower, the force that's making this acceleration happen is pushing that way, isn't it? So that's a negative acceleration. So let's do this again. Starting with a negative displacement, I could do the same thing starting over here. It would be a positive displacement. I start fast and get slow. That's a negative acceleration. Let's do the same thing over here, starting with a positive displacement, just to show you the same thing. Start fast and get slower. That is a positive velocity, negative acceleration. Now eventually, I start fast, get slower, slow down, slow down, slow down, slow down, slow down. Now eventually, I'm actually going to turn around and start heading back in the other direction and move faster and faster and faster and faster. So, oh dear. So if even with a constant acceleration, I slow down to 0, and then, well, if you think about it, if the velocity is positive, but smaller and smaller and smaller and smaller, eventually the velocity is going to get to 0 and then keep getting smaller. In other words, become negative and start moving back in this direction. If you've got an object that is moving that way quickly and you push backwards on it, if you push in that direction on it, what's going to happen is it will slow down. If you've slowed it down to the point where it stopped, but you keep pushing that way, you keep the force going that is making that acceleration, it is going to turn around and move in that direction, okay? So a negative acceleration, a constant acceleration, but a negative acceleration can turn the velocity around. The displacement goes from negative to positive and back to negative. The velocity goes from fast to slow in the positive direction, then slow to fast in the negative direction, okay? That one's a little bit counterintuitive because you think of it as this is an acceleration. It's actually a slowing down, first of all. So an acceleration is just a change in velocity. So a deceleration is still called an acceleration. It's just it's a slowing down. It's acting in the opposite direction to the velocity. And the other thing is you think of a deceleration. It's a braking, isn't it? You're just slowing down. Now, if you hit the brake in a car or on a bike, once you get to 0, once you stop moving, you stop. You don't suddenly start turning back around the other direction. But a constant acceleration, again, think of it like a force. There's a force causing that acceleration, so you keep the force going in a constant sort of way. So once you've stopped, you're not actually going to stop and stay stopped for any time. You're immediately going to start moving in the opposite direction to the way you were going. Okay, so recap. Positive velocity and positive acceleration means start slow, move faster. Positive velocity and negative acceleration means start fast, move slowly, get slower and slower and slower until eventually we turn around and then move faster and faster and faster in the negative direction until we shoot off to the left. Okay. So what's left is if we start with negative velocities. So negative velocity and negative acceleration. That's the easy one first of all. The acceleration is acting in that direction, in the negative direction, and the velocity starts off negative. So I start slower and I move faster and faster until eventually I shoot off. Negative velocity and positive acceleration would be, you start somewhere, you move at a certain speed until you were going in the negative direction, we slow down, negative velocity, so the velocity is going that way, positive acceleration, so the force that's causing the acceleration is pulling that way. So I start quickly, go slower and slower and slower until eventually I stop, and then the force keeps going, the acceleration is constant. So I'm going to start moving this way, and eventually I move faster and faster and faster and accelerate off that way, okay? So a positive acceleration and a negative velocity is a slowing down, is a deceleration, until eventually you stop and speed up. Another way of thinking about it, I suppose, is you could say, if you've got a positive acceleration, eventually you're going to have a positive velocity, right? If you've got a positive acceleration, it's going to be pushing everything in the positive direction. So eventually the velocity ends up positive. If you've got a negative acceleration, even if you start off moving in the positive direction, you're going to have to turn around and get back in the negative direction and speed up and shoot off in that direction. So that's perhaps a helpful way of doing it. Have a look at example 5 and make sure that these numbers here tie up with what you've got in the blue box. Another important sort of way of thinking about it, I suppose, is that slowing down could be a positive acceleration, could be a negative acceleration. That depends on whether your velocity is positive or negative, okay? So a slowing down or a deceleration or a retardation all mean the same thing, but that doesn't tell you anything about whether it's a positive or a negative acceleration until you also know whether it's a positive or negative velocity. I and J notation we should have met already in the pure book, so I'm not going to talk about that one. And I don't think there's much to add for these examples other than what it says here. You know, from the pure book, you know how to find the magnitude of a vector. Distance is the magnitude of the displacement vector. So if you know the displacement vector, you know the distance. At the time of me doing this, there isn't I think it's chapter 11 of the pure book. I haven't done any pure videos. It will be months before I get around to them. So if it's November 2018 and you're looking at this, you know, you've got a long wait from me, but I'm sure you've covered that chapter in pure. And if you haven't, and you're trying to learn this for some reason, then have a look at the pure book, chapter 11, and then come back to this. And I don't think there's very much I need to say here. Apologies if that was the bit you were looking for help on, but there it is. I think everything it says in the examples will do the job for you. And just one final warning: you know, if you watched more than one of these videos, then I've said this already on chapter 8 a lot of times. But chapter 8 will sink in properly when you come back to it after having done chapter 9, and possibly chapter 10 as well. Okay, so it's an introductory chapter. It's giving you a few ideas, so that we've got some sort of context for what comes next. It doesn't fully make sense until we understand a bit of the context, but we had to give you some information to start you off with. Okay, that's chapter 8 done.